Example 1. Minting quarters using the confidence interval method. U.S. Mint specifications require that quarters manufactured after 1964 have weights with a mean of 5.670 grams and a standard deviation of 0.062 grams. Listed below are weights, grams, of a simple random sample of quarters made with a new minting process designed to reduce the standard deviation so that weights of quarters are more consistent. Use a 0.05 significance level to test the claim that these weights are from a population with a standard deviation that is less than 0.062 grams. So we have the population standard deviation, which is at 0.062. What we want to do is enter this into StatCrunch to find out what the standard deviation is. So what you're going to do is you're going to create a column in StatCrunch, call it the weights of quarters, and then enter the values in here, and you're going to see that we get 24 values. Now we're going to go ahead and go to Stat, and then go to Summary Stat, select Columns, the weights of quarters, find the sample size and the standard deviation, and then we're going to select Compute. So these are the values that we want to keep track of when we're finding the confidence interval method. So we're going to go ahead and copy that and then use that for later in the problem. Okay, so now the first thing we want to do is we want to talk about the confidence interval method. Okay, so for the confidence interval method, recall that because a confidence interval estimate of a population parameter contains the likely values of that parameter, you reject the claim that the population parameter has a value that is not included in the confidence interval. And here, the confidence level for the confidence interval is the following. So you have your two-tailed and your one-tailed test with a specific significance level for the hypothesis test. So, step 1, first we should be careful to select the correct confidence level. Because the hypothesis test is left-tailed and the significance level is 0.05, we should use a confidence level of 90%. If you come back here, the claim is stating that it's less than. That's why it is left-tailed. And therefore, we're going to take a look at the following. We're going to say that, okay, since it's a left-tailed, it's going to be technically a one-tailed test. And we know that the significance level is 0.05. And therefore, we're going to be using the 90% confidence level, or 0.90. So, now that we have that, now we can go ahead and proceed with the confidence interval method. So we first need to find the chi-square left and right critical values that correspond to a 90% confidence interval. Because in the formula, we need to know both the chi-square left value and the right critical value as well. So the first thing we need to do is take a look at the degrees of freedom. So the degrees of freedom is 24 minus 1, which is going to give us 23. Now that we have the degrees of freedom, now we need to find alpha. Well, alpha is 1 minus 0.90 because it's a 90% confidence interval, which gives us 0.10. And since we need to find the right and the left critical values, we need to take alpha and then divide it by 2. So 0.10 divided by 2 is going to give us 0.05. So let's go over here and then draw our chi-square distribution. So recall that a chi-square distribution starts at 0. Okay, and then what we want to do is we want to find out what is the chi-square value here on the left, and then what is the chi-square value here on the right. Okay, so we do know that the area to the left here on this side is going to represent the value of 0.05. Okay, and so we want to be able to find the critical value on the left that has an area to the left of 0.05. And so this is also another area of 0.05, and that's to the right. So let's go ahead and shade that. Okay, so if we want to be able to then find the critical value on the left, then what we're going to do is the following. We're going to open up StatCrunch. We're going to go to Stat, go to Calculators, and then go to chi-square. We're going to make sure our degrees of freedom is 23. Okay, and we want to find out what is the critical value here when it's less dense, because we want to find the area here, and we're going to put in the area that we found to be 0.05 and then press compute. And therefore, that's going to give us the critical value on the left. Okay, so that critical value is equal to 13.091. Now we want to find the critical value on the right. So to find the critical value on the right, we're going to come up here to select options and then select refresh. Again, put on our degrees of freedom of 23. We want to change this to be greater than or equal to, but then we got to put in the area of 0.05. So we're going to enter in the 0.05 and then press enter, and then that's going to give us the critical value on the right hand side. So there is the critical value there. And so that critical value, rounded to 3 decimal places, is 35.172. So now that we found those critical values, now we can go ahead and then proceed with our problem. So here, again, we can see the critical value on the left is 13.091. Critical value on the right is 35.172. So now what we're going to do is find the 90% confidence interval estimate of the population mean. So what are the things that we know? Well, we know that the sample size is 24. We also know that from the very beginning, we saw that our standard deviation was 0.040164. And then we have our chi-square to the left and chi-square on the right value. And so now what we're going to do is we're going to use this formula for the confidence interval. So you have n minus 1 times the sample standard deviation squared over the chi-squared to the right. And over on the right hand side, n minus 1 standard deviation squared over chi-squared to the left. So let's go ahead and plug in our values. So again, we know that the sample size is 24. We're subtracting 1. And then we're going to multiply that by the sample standard deviation squared. And then over here, we're going to divide the one on the right by the chi-square on the left. And then we're going to divide the one on the left by the chi-square value on the right. So let's go ahead and do this on our calculator. Okay, so let's first find this value, and then we'll take the square root of it. So we're going to say parentheses 24 minus 1, and then we're going to multiply that by 0.0480164, and then we're going to square that value. And then we're going to divide that by 35.172. And then we're going to take the square root of that answer. So second square root of that answer. And then that gives us the following. We get the following. So we get 0.03883 rounded to 5 decimal places. Now let's do the other one. So we're going to take 24 minus 1. And then we're going to multiply that by the standard deviation squared, 0.0480164, and then we have to square that result. And then we're going to divide that by 13.091, and then we're going to take the square root of that answer. So second square root of that answer, and then that gives us 0.6365 rounded to 5 decimal places. So therefore, we would say that with this confidence interval, we cannot support the claim that the standard deviation is less than 0.062, because the value of 0.62 is in this confidence interval. It's less than this value on the right. Therefore, it's contained within the confidence interval. So the confidence interval is telling us that the population standard deviation can be any value between 0.3883 grams and 0.06365 grams. The confidence interval is not telling us that the population standard deviation is less than 0.062 grams. We reach the same conclusion found with using the p-value method and the critical value method.